Okay, today is Tuesday, October 8th, and we are continuing along in Go Math today. We're doing Go Math Chapter 5, Lesson 5. And we're going to use everything we've learned so far about factors and multiples and divisibility rules. And today, by the end of today, you should be able to tell me whether a number is prime or composite. I've already introduced this idea to you a little bit sometimes in library or when I excuse you guys to go out to lunch and some of you are like, hey, Miss O, you never call my number because my number is prime or not, right? Okay, or Sachi's like, Miss O, I'm always the last one because I'm 1. And we're going to talk about number 1 a little bit later today, okay? But first, let's talk about our problem of the day. At the top of lesson 5.6, it says, students are arranging square tables to make one larger rectangular table. Okay, so each table is a square, like the white table we have there. If I put 2 white tables together, wouldn't that make a rectangle? Look at my white table. Is it a square? Look at it. Point to it. If I put 2 of them together, would that make a rectangle? Yes. So that's what students are doing, okay? They're trying to put square tables together to make one larger rectangular table. The students want to have several ways of arranging the tables. Should they use 12 tables or 13 tables? Okay, so there you have a grid of paper, and it says use a grid to show all the possible arrangements of 12 and 13 tables. Let's talk about 12 tables first. What are some different ways to show 12 tables? Well, they have 1 by 12. Okay, if I turn it like this, by the way, that's the same arrangement, right? 12 by 1. Okay, so we're just going to call that the same. What's another way? Could I have 2 square tables right next to each other? If I do that, how many in a row would I have? Everyone? 6. So go ahead and draw that and write 2 times 6. Could I also have 3 in a row? How many would be across then?
4.
So let's write 3 times 4. And then my next one would be 4, but that's the same as 4 times 3. Do you guys agree? So how many different ways could I arrange 12 square tables? 3 different ways. Good. Now, let's try to draw 13 tables. What's one way I could arrange 13 tables in a row? I mean, all together. 1 and then 13, right? So go ahead and draw 1 by 13. And go ahead and label it 1 times 13. Is there any other way? Could I put 2 in a row? 3 in a row? Huh?
No.
Because I can't do 13 divided by 3, right? 4 in a row? 5 in a row? 6 in a row? 7? 8? 9? 10? 11? 12? 13? Oh, okay, good. But that's the same as what we already have, right? So are there more ways to arrange 12 tables or more ways to arrange 13 tables? There are more ways to arrange 12 tables. In this little blue box up in the corner, what are the factors of 12? Let's arrange the factors from smallest to largest. 1, 2, 3, 4, 6, and 12. How many factors of 12 are there? 6. It's these 6 right here, right? How many factors of 13 are there?
2.
What are the factors of 13? 1 and 13. Huh, interesting. Based upon what we learned in that example with the tables, we can see that a prime number is a whole number greater than 1 and has exactly 2 factors, 1 and itself. 13 is a prime number because it has exactly 2 factors. 13 only has 2 factors. It only has 1 and 13. That's the only way to make 13. So, 13 is a whole number that is greater than 1. It has exactly 2 factors, 1 and itself, 13. A composite number is a number that is not a prime number. It's a whole number that's greater than 1 that has more than 2 factors. So what were the factors of 12 again? 1, 2, 3, 4, 6, and 12. How many factors does it have? 6. 6 is more than 2. It has more than 2 factors. What are the factors of 13? 1 and 13. It has exactly 2 factors, 1 and itself. So what kind of number is 12? 12 is a composite number, and 13 is a prime number. You can use divisibility rules, just like we just did with our classroom numbers, to help tell if a number is prime or composite. If a number is divisible by any number other than 1 and itself, then the number is composite. So we want to know if 51 is prime or composite, okay? So let's just check. Is 51 divisible by 2? How can we tell that 51 is not divisible by 2? Avani? It is not even. It is an odd number. So therefore, it cannot be divisible by 2. Is 51 divisible by 3?
Yes.
How do you know that, yes, 51 is divisible by 3? Evan? 5 plus 1 is 6. And I know my math facts. I know 6 divided by 3 is 2. So therefore, is 51 composite or prime? Everyone? Composite. Because if it's divisible by 3, that means it has more than 2 factors. It's more than just 1 and 51. So therefore, 51 must be composite. Over here, there's the math idea that I was just telling you guys about. The number 1 is special. It is neither prime nor composite because it only has 1 factor. In order to be prime, you have to have exactly 2 factors. In this math talk, it's very interesting. I think it's a really good question. The product of 2 prime numbers will always be composite because it will always have at least 2 factors, which are those 2 prime numbers. Do you guys agree? Whatever you multiply to make that product, those numbers are factors. And then you'll always have 1 and itself too. So the product of 2 prime numbers will always be composite.